Everyone, geometry, mod 5, topic 1, lesson 2. We're on page 789 for you to know, and I'm going to recommend that you have a highlighter, have a pen, something to write with, and let's get into it. For starters, what we're talking about in this lesson today, launching the idea of compound probability using the word and, which we've seen and show up in the descriptions from like the introductory lesson 1, whenever it was, but we're going to really dive into like what it is, how we use it, and then what mathematics you need to remember to follow in order to answer it. I also want to comment, like, this idea of the counting principle was the bulk of the last couple of videos, but it all summarizes down to this. You take your number of options for the first event, your number of options for the second event, and so on, and you multiply them. And that would give you like a combined total number of outcomes. I think, hint, 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 that's my reminder for lesson 2. Over here on this side of page 789, we have some key terms. We have the term compound event. That's the big one. We have the rule of compound probability involving and. I'm only going to highlight the and. And then the last vocabulary word for this page is conditional probability. So I'm going to highlight, make those available. The learning goals for this entire lesson, the next string of videos up through about page 800, are all based upon determining the probability of 2 or more events that are independent and determining the probability of 2 or more events that are dependent. Let's do the review together. Questions 1 through 4. Determine each product. And once again, let's see, we get some focus on there. Sorry, I'm doing this on the fly with you in the moment. Here we go. Number 1 and number 2. And number 3, number 4. Here we go. So determine the product. All of probability is based upon understanding the mathematics of fractions. You learned how to handle fractions up through 8th grade, so this is a chance for you to remember what those concepts are telling you and how to solve them. I'm going to show you 2 paths for the first question. First of all, multiplying fractions. The easy rule to follow is to multiply straight across the numerators, straight across the denominators. So number 1, the 4 times 1 would wind up being the top of the fraction, because that 4 and that 1 are across the numerator. And then on the bottom, 5 times 4. You just do the mathematics related to what's happening on the top of the fraction. 4 times 1 is 4. 5 times 4 is 20. And we could call that done. That is the correct answer. It's not reduced. It's not simplified. It's not in a decimal format. So maybe we should go one more step further. And in order to go one step farther, I'm going to go back and look at really, I could say the second fraction of the first fraction. I'm going to pick the first fraction. I already know, we should know, from multiplying fractions, we're going to multiply straight across 4 times 1. And on the bottom, 5 times 4. So at some point, there will be a fraction with a 4 on the top and on the bottom. And whenever that happens, a fraction made up of a number on top divided by a number on the bottom, that cancels to 1. Reduces to 1, divides to 1. So the 4s really are actually able to be tossed out. We don't need them. They are going to divide each other to make a 1. And then it's like there was no 4 to begin with. It was only a 1 on the top and a 5 on the bottom. Done. You can go to your calculator. You can do that. 1 divided by 5 is 0.2, 20%. That's for a different situation. Now we have number 2. Again, it's still mathematics of fractions. It's still multiplication of fractions. So multiply straight across. Straight across. 1 times 3 is 3. And 6 times 5. This only happens nicely with multiplication. That's why we're doing it now. 6 times 5 is the bottom, and that makes 30. But this is a similar situation as question 1. If there is something that can be reduced, divided to make a simpler fraction, then we should do that. And I know that right here, the 3 and the 6 are multiples of each other. And that it takes 2 3s to make a 6. It takes 1 3 to make a 3. So the fact is, in this section of question 2, the 3 and the 6 can be reduced. 3 divided by 6 is 1/2. The 3 becomes a 1, the 6 becomes a 2, and our mathematics really can be written as 1 times 1 on the top and 2 times 5 on the bottom. That's the reduced fraction. That's a much simpler fraction to even try to manage. 3 divided by 30 is the actual numbers being multiplied and written as a fraction, and it is the right answer. But it's not like the simplest or the best answer. Or maybe not like just the most like efficient answer. Best is kind of relative to the context. So maybe 3/30 is the best answer. We want efficient. Okay, question 3. In question 3, we have 5 times 3 over 8 times 7, and there is nothing we can do with those. The 5 and the 7 can't be reduced. 5 and 8 can't be reduced. 3 and 8 can't be reduced. 3 and 7 can't be reduced. So there's no cancellation that can happen. We're just going to have a really gross, ugly fraction. Gross and ugly fractions because the non-reducible values make 15, that's 5 times 3, over 56. And like we're not really ever going to see a 56 fraction. It's obtruse. Okay. Number 4, I'm going to use that trick. Before I even start multiplying straight across, I'm going to use the cancel trick. And there's a couple of different arrangements that I could cancel, but I might as well go the easiest path. And the easiest path is the 2, that's the numerator in the middle fraction, and the 2, that's the denominator in the third fraction. Since numerator, denominator both have 2's in them, they cancel out. They divide to 1. So they're gone, and I'm left with a 1 in their place. Not 0, not gone, a 1 is left when you make a cancellation. Now across the top of the fraction, it's 1 times 1 times 1. Which is really easy math. Come on now, find the easy math to do, the stuff that you can do mentally without a calculator. In the bottom of the fraction, it's 4 times 3 times 1. And 4 times 3 makes 12. And because we have a unit fraction, 1 over 12, there's nothing left to reduce. That is the final part of this question. We are done. Let me go ahead and refocus on the last part here. There's this sentence at the bottom of page 789. You've used tree diagrams and organized lists to determine the sample space and calculate the probability of events. There's so much vocabulary going on in there. I'm going to highlight all of it. We've talked about tree diagrams. We've talked about organized lists. We've talked about sample space. We've talked about probability, and we've talked about events. You should be familiar, more than familiar, with those 5 vocabulary phrases. 5? 1, 2, 3, 4. Yes, 5 vocabulary phrases. If you're not, go back and watch the previous videos. Now, our question of this lesson is how can you calculate the probability of compound events that are combined by the word and? With that in mind, that's what we're going to focus on in the next section of videos, about 10 of them or so. So thank you for watching this episode. Appreciate your patience and observation and thinking going on today. Click forward to the next video, like, comment, and subscribe. Just joking, whatever. And I'll see you in our next video.